Hello.
Good morning. How are you
Morning.
guys?
All right. How are you?
Doing pretty well.
Good. Hello, Jesse.
Good morning.
Morning. So, welcome to the meeting. I know that a couple people expressed interest in presenting today. I don't know when they'll show up. I know that Vrushali might present on her. She went to a conference on virtual worlds. That'll be interesting to see. And then I think Ankit may have a presentation. I don't know what the plan is yet, though. But we'll talk about, of course, Neuromatch. This is the second week, and a few other things. So if we have updates, if someone would like to go.
Sure. So this past week, we had the Cognition Futures reading group meeting where we finished the paper by Raha about resonance. The paper was trying to give like a rigorous theory of Gibsonian resonance, which is something that Gibson only mentions like a handful of times and is pretty vague, more vague than information, which has been talked about more. And so the paper argues that, with this dynamic systems theory, like multi-scale fractal dynamic systems theory, you can actually describe this phenomenon with like equations. So that was a really interesting discussion. And then on Thursday, we met for the human use of human beings reading group, which was also very good. We read chapter 5, which was about, so in cybernetics, you have the idea of like the message versus the noise. And Weiner talks about how the organism can be seen as the message and the environment with increasing disorder can be seen as noise. And so he runs with that metaphor. And one part that I really enjoyed talking about was like this personal identity issue. Kind of like a sci-fi thought experiment. Like, would it be possible if we knew everything about the physical matter? Would it be possible to like recreate an organism, a particular organism elsewhere? Like get all the information you need and then build another version. And he says yes. Like there are technical obstacles, but in theory, if you could recreate like the organization, not just the parts, but how the parts are interacting, and the organization, then you could recreate the organism. He has a line that I really liked that was like, the identity of an organism is more like a flame than that of a stone. Than a stone, like it's not just a matter of, matter, it's not just the substance, it's the way, it's the processes that unite the parts. So that was a good discussion. And then we should be hearing back from the Society of Philosophy of Science of Mind conference soon. I'll probably be gone and not have Wi-Fi when that happens. I'll be gone for a few weeks and I won't even have reliable like service. So I'll be a little off the grid, but hopefully we get good news there.
Yeah. Do you have like someone who can like get the news for you? Like
I'll be able to find Wi-Fi occasionally, so I'll try to check.
Okay. Yeah, that's great. That's all very good. And yeah, that discussion we had in human use of human beings actually was very good. It kind of went from, I think it skipped from Cognition Futures reading group to that group, and then there's a lot actually to say about the thing about personal identity, which we should follow up on. But that's of course where, and for those of you who weren't there, it's basically if you were to twin or to clone an individual, if they were maybe to be teleported, you could replicate their exact being and likeness, and it wouldn't matter. Like, and you could transfer the memories, so you could do that. And the thought experiment is, would that be possible? And the people, they're advocates for yes or advocates for no. There are some interesting empirical sort of analogs to that. One is in the realm of cloning. So we can clone like, sheep and goats, and it's, something that is relatively routine at this point. I mean, it's not difficult. People know how to do it. It's basically taking the same at the level of an ovum and a somatic cell, and taking the nucleus from the somatic cell, putting it into an ovum, and basically cloning an organism. They call it indirect reprogramming of cells, and then you can implant that embryo into a goat or a sheep or a cow, and grow a baby, and it becomes an adult. And one of the problems they have is that it doesn't actually clone everything, like at the level of identity. I mean, there are a lot of things that are similar, but there are a lot of errors that occur and things like that, which is an interesting empirical observation. I don't know, how that relates to the problem. Of course, there's also teleportation, and this is more speculative, but in Star Trek lore, people have actually debated what happens when you teleport someone. Is it that you take the information, move it to another place, destroy the old body, and recreate a new body, like what Jesse's showing? Um, and there are whole debates about this. Of course, there are. But the point is that if you were going to create a system like that, what would it look like? Would it be possible to, say, create a twin by moving it to another set of matter and just the information? So that's that. There's also this digital twins idea that we've talked about in the meeting. So we're creating these virtual models of things in the world, and some of them are mechanical, some of them are biological, some of them are neither. But the idea is to make a twin, an exact replica of the physical object, or the thing that has a physical presence. And so again, you have to replicate all the interactions, all the information, as detailed as you can. That's the goal. But the question is that the same thing? And I don't know. I don't think you could do that. I mean, you certainly can't now. I mean, you can replicate the processes and all that. And in that sense, we've had that ability for hundreds of years. As Morgan has a link on digital twins. Okay, great. In the chat. But it's like model building. We build a model of some system or process, and it's some abstraction. So we take away like the stuff that we don't think is important, and we have the essential stuff that we put in. So that's like a thing that we know how to do, and we've known to do that for a long time. The question is how much stuff is essential, how much stuff is necessary to make this sort of something that's virtually identical. And I say virtually identical because it's like there could be things that are different, but it wouldn't matter. And so there are a number of empirical ways you can kind of look at that. It's kind of interesting. I don't think anyone's written that paper and said this is something that we have sort of analogs in the world that we could maybe look at and evaluate them a little bit. But
can you say more about the paper? Like what, like evaluation towards what ends? Like what would the paper look like?
Oh, I guess it would just be like motivating the philosophical question, and then having some empirical examples. And again, there's not a lot of work that's been done on this other than just knowing what the outcome of some process is. If you're making a copy of something, or cloning something, what does that look like? Is that consistent with Oregon's idea that you can make a digital or like a twin something, copy the every aspect of it, or just copy certain aspects of it? It's almost like we're simulating things sometimes in real life with technology. So if we did like reproductive,
important cloning. For the personal academic Oh, sorry. Go ahead.
Oh, well, I was just going to say with reproductive cloning, you're simulating an individual with, we're not like saying, I don't know how, I don't think people are arguing we're making exactly the same organism, but it's like, we're taking the essential parts of that model and replicating it. So.
Right, because you can't have exactly the same organism if it could be like exactly similar, but the question of personal identity in philosophy is like basically one way to frame it is like, what can the organism survive? Could we survive teleportation? It's less about like copying and making something perfectly similar, although that's also very interesting, but the debate is often like, what would it take for the organism to persist? So I think what Weiner is talking about is this second question of like, if you could, it's not about copying the organism and making a second one, it's about creating like one and the same organism in a different place by reconstructing it in a certain way. And that same organism like survives that transition. So in the personal identity debate, it's like, if the original still exists, then what you've created is it's not identical with the original, because you can't have A identical to B. You can't have two different things that are one and the same thing. So the digital version of this question would be like, could you upload your mind to a computer? And the original is what, there's like a transition from the original to being the digital version. It's not just a copying. It's like, a true identity through time. So yeah, the question of if you can make something perfectly similar is also relevant, because if you're allowing the original to like survive, then the new version has to be like similar enough. Although our bodies do like change through time, so it's not like in the real world there's like perfect qualitative identity through time either. But yeah, that's really interesting, the digital example. Yes, cyberpunk discussion.
It's ironically this or in the previous conversation that we can go into this as much as we want to a little today, but just it's really interesting to take this exact concept and look at Cyberpunk 2077, which is a video game that's out now, but with the concept of that exact issue being central to the plot line, and also like this digital twinning stuff that we've talked about, and I think there's even I saw another GIF I'm gonna try to do of this GIF here, where you can kind of I went in detail with this in the meeting, but basically there's something called a brain dance component to Cyberpunk, which is like this. I think it's actually a really great bridge from the original critique paper that started off a lot of the current methods project, which was saying, hey, did Varla's embodiment actually go anywhere? And why not? What are the methodological limits of that? Well, let me suggest film. That was kind of Martini's critique, and saying, what are the methodologies where we can do more embodiment? Brain dance as a fictional concept in cyberpunk world is like this extremely high definition, multi-sensory recording. You have audio, you have visual, you have heat, you have not just first person experience, which is the main view, but this amazing magical ability, but technology as magic in this sense. There's technology enough where, you can just easily switch between first person recording of what it's like to be in someone's body, to see what they're seeing, like to see that, and then also to immediately just happen to step out into third person perspective, to step into a situation that's more external to the individual that was recording it, and then also be able to actually move your focus around the proxemic area. There's a limit to it, but it's almost like this space-time, like you're recording proxemic space-time around the person to an extent. And it's quite, that's almost an impossible technology in one way, but it really dovetails interesting with the conversation that Norbert Weiner had in the book that we talked about. It dovetails with a lot of the other things we're talking about, and it fits. It's a really interesting. I'm not really like the biggest fan in the world of the video game. I don't really care about the game, but like conceptually, it's sort of this science fiction realization of if you had the technology that could do this sort of high fidelity recording, which is extremely key to some of how the game's told, and also related to the main thing about the digital twinning, about what can where would the source of something be, and what happens when there's different different things taking place in the context of the game, as far as I understand it so far. The main plot line, and I'm going to semi-avoid spoilers, but like I don't think anybody really cares either. But just one of the main features of the thing is like there's essentially at the time, which I guess is around this current time, like this in the game's universe in 2020, there's an experimental technology that lets the recording happen. And then later on, that doesn't just do the recording, but does a sort of capturing an entire. It's like the uploading the person into the computer, and then there's a downloading of that person into someone else, or into a storage capacity, and then it's downloaded into someone else's head. In 2077, there's all this kind of like cyberware and upload, download, and what's normal in that situation is different to the normals of now. But it's this question of if you did duplicate such a thing and you put it in another human body, what would happen? And that's kind of the story. Well, part of it anyway. So yeah, it's really interesting stuff to think about. I think I didn't play the game on purpose to reference this, but it's funny that it's blatantly in my face as we're talking about this with the Norbert stuff. To kind of come back a little more to concrete stuff, I would just follow up by saying, yeah, it's been really interesting to read the book in the context of what our discussions, the Norbert book, but also to try to explore what I'm trying to do in like when I'm cruising for like certain bookstore finds basically, and trying to get this sort of temporal perspective on some things that Norbert's like this very clear like 1940s viewpoint, 1950s maybe, and then I'm doing a lot of stuff. My update is basically all of that plus I want to finish the oral. I don't know if we're going to talk about it later today, the mid-year review, which is basically ready. It's just, do we want to add another like, commentary on some of like deep dive stuff. The review part of it, which is pretty just a recap, is there. Like it's set. And thank you people who contributed to that. But also like I spent, what is that? I don't think I can show this very well, but maybe I can. I spent a little bit of time playing around with I don't know if it's fair to call it a mapping technology, but let me try to show it here. It did a combination of a few things. I'll show this really quickly. There's an open source, or not open source, but like community, I don't know, free for open access kind of a thing, version of this mapping. It's called Kumu.io. And I'm just playing around with it. Like, it's mostly kind of a way to visualize databases. Like you can kind of see a label and then you can type and tags and stuff. And it might be easiest to literally just import like a CSV file or an Excel sheet or something. You can kind of see like here's. I'm mostly just experimenting with this right to see if it's useful to visualize certain things, including other like broader research agendas I'm trying to map out. But for like the sake of our purpose right now, you can see, it's kind of a nice way to show some of the relationships between like organizations or working groups and tools and stuff like that. And I'm playing around with like different concepts and ways to relate them. And I don't have a reason to say this is useful right now, honestly. Like I want it to be. I think if you have a nice data, if we pulled some stuff from Notion and turned it into a CSV file, it'll be a nice way to visualize that. As far as making things here, making the connections, which is sort of a nice thing. There's a view specific to connection, which is kind of cool. Basically connections are two elements and the relationship between them, like coming or going, and loops are like groups of three or more, I guess. It's just this kind of interesting relational database visualizer, I guess, and like you can do different templates and stuff, but I don't have any strong like use cases for us yet, other than visualizing some stuff. But yeah,
That's great. Looks good.
so
Yeah.
It feels like, yeah, that's great, that's what we need, and then it's like using it kind of clunky, and I want it to be great, and maybe I can use it better, but we'll see. My only other update is that, yes, by the way, we are accepted at WeRobot 2023. I'm doing a frontier map thing for that, and also a plot twisters thing for that. On plot twisters front, it's kind of slow right now. We're kind of taking a summer break, and we're taking this break. We're going to be doing a break for like, I think Cognition Futures and also the reading group for the next couple of weeks. That man is going on vacation. I might meet up about, and I don't know if you want to talk about this more later, but I would like to talk about like the cybernetics project, or just, I guess the fun thing on my mind is a much broader sense of I want to make, I don't know if it's going to be a full working group or something, but like I need to structure my efforts in the history/philosophy of science arena. And I don't know what form it's going to take, but there's going to be opportunities to do things related to that. And a lot of it's dovetails with some of the Cognition Future stuff, but it's also just like, I want to get a little more literate in like the customs and conventions and norms of talking about some of the science, philosophy or history of science, and going from there. I've seen. I think I didn't get that book. Just to show this for a moment. Here we go. There it goes. So I found these books at a different used bookstore around here. These all looked interesting. I actually do want to dive a lot more into phenomenology and ethics, because I think that's a key arena for some stuff, and maybe this is something I would like to talk a lot more with Amanda. I know there's interested in about like the identity stuff, because I think that's kind of its own arena, and like it's definitely an arena for the message project, and I think but I feel like it's also its own concentrated thing. But between our discussions, oh my god, and between like some things that have come up when looking at like the India's Hippolyto podcast and some of her work there, and the way she's talked about the sort of ethical implications or frames of view that phenomenology brings about. Like, there's something there I want to do. I did not get that book though. This was like a really interesting book too, also about like kind of the or harkening back to our FQX3 problems from a while ago, FQXI, I mean, but it was like indeterminism and all these different like I forget what it was, but it was about kind of this sort of thing. I did get the Chomsky book though, because I need to branch into Chomsky to understand some of what his was about, and I think this would be an interesting bridge. I wish I don't have a picture right now, but the back of this book, the language and learning debate between these two. It has a bunch of like a bunch of contributors into it. It has like Fodor, it has a lot of Papert in it. It has some other people in the book, like offering commentary, being a part of the debate or whatever else. So it was kind of a really cool, like, oh, this is a great Macy's conference-ish about this topic and with different people at the time. And I say that as I don't know if chagrin's the right word, but I say that with a sense of, on the back of the book, from the forward, there's this big block quote that they pull out on the back of the book, and it basically says something like, "Oh, the historical debates of cognitive science, you know, there's much debate about how cognitive science emerged, and you know, blah blah blah. But one thing is for sure, there was never like an unprecedented moment was when Piaget and Chomsky met, and they were ready to take into the future this tremendous cognitive science. Like, oh, that was like the starting point of so much important stuff." And it feels pretty ironic to me. It's like, well, that probably was the cresting of a lot of linguistics as AI at that time, and it was like super full of hope. And I just feel like 50 years later, 40 years later, what would that person feel now? You know, like, where did it go? Why didn't it go that way? Anyway,
So you're saying all hope is lost?
well, it's just another winter or a summer. That was probably a hot summer for linguistic stuff. I think it was around 1980s when that book was, or when the debate was.
Okay.
There's somebody who I couldn't, and on the book there's someone named Herod, who has signed it. I don't know if it's a person. I couldn't see it was like an author or contributor. I couldn't really read it, but it was 1980, and it was like, okay, that's cool. But I don't know. And the book's interesting because of my interest in like I think it's a great resource for what people were thinking about in that part of cognitive sciences development. Which, just for those if you're just joining for some reason, I'm pretty agnostic, skeptical towards cognitive science as a project as it has been, and I'm kind of differentiating my feelings about that versus the really interesting work in the paper I submitted to the conference we just mentioned, like Inez Hippolyto and Company's International Society for the Science of the Philosophy of Mind, ISPSM stuff. The one I submitted something about analogies of the mind. And I feel like I kind of did that on a whim, and now it's like I think about it a lot, particularly in reference to the Cognitive Science Project and the brain as a computer and the role of computation and where in cognition is the computation happening and why and all these things. And so I just feel like the book is interesting in the sense of where what people, the zeitgeist, but also I think it's a good I don't want to say fodder, but I think cognitive science and cybernetics are both these fascinating is a nice word for it. Interesting arenas for philosophy and history of science to kind of be, I don't know, lenses, I suppose. So I got it for that reason too, to kind of just see the comparison in that sense. Anyway, that's a kind of wide-ranging update of my thoughts and feelings about things. There's more to say, and I'll probably dip back into some of the stuff. But it'll be a little bit slow on cognition features and plot features front. Society ethics tech is kind of on hiatus too. But I think the next big thing will just be finishing the mid-year report, which we can maybe talk about later. But that's all for me.
Okay. Yeah, that's great. Thank you, Amanda, for your update, and Jesse for your update. And so yeah, that was a nice discussion. So hello, Vrushali. How are you?
Vrushali.
I noticed that you put something in the chat. Yeah.
Actually, I'm gonna do a little bit of presentation for
Okay.
my what. So shall I start now or?
Yeah, go ahead and share your screen. Yeah.
Okay. Let me.
Okay.
You can see this. Right?
Yes.
Actually, I write a document instead of making a presentation.
Okay.
So let's get started. Hi, for those who don't know, like future reference, I'm Vrushali. I attended the Educational Data Mining Conference 2023 at ISC Bangalore. So here are my insights, like what are the learnings I got from the conference. So basically, the agenda of the conference was the educational data mining. What is educational data mining? Educational data mining stands for like mining the data for educational purposes. Like there are MOOCs, MOOC, massive open online courses where a huge number of data is collected by the organization who is uploading or whatever course they are having. So like collecting the data, analyzing it, and making insights for future references was the huge like the actually idea of this conference. So I'm going to just cut down the process how it's gonna do. So let's get started. What is educational data mining? EDM stands for educational data mining. It can be defined as technique for finding the specific types of data that came from the education system and implementing those techniques to understand students and the system better. EDM is the process of transferring raw data obtained from educational systems into useful data that can be used to make data-driven decisions. The development of data mining and analytics in the education field was relatively late as compared to the other fields. However, it is challenging for educational data mining via the web because the specific features on data, while numerous types of data have sequential aspects, the distribution of educational information over time has extraordinary attributes. Educational data mining techniques have been fruitful and creating a range of phenomena concerning students' learning on the online platform and accomplishing better accuracy consistently. There are significant aspects that need to be examined to justify the extraordinary advancement for educational data, which is developing acknowledgement that not all the key data is stored in one data stream. Research in education has resulted in a few new educational enhancements computer-based innovation have changed the way we live and learn. Like today we are connecting remotely, and like lots of things are gonna applicable if we use the MOOC, like we use YouTube as a learning platform, or there are sources like Coursera and other stuff. So these models are used in educational data mining. There were also a paper where a person described about her learning, like how she collected the data from the students, the participants in that course, and analyzes it and then further improve it for future references. Like there was the paper about that. So like I'm not gonna skip this thing. Data mining is the most powerful technique with incredible potential to help school, university focuses on the most significant information in the data sets they have collected about students' behavior and potential learners. Data mining uses its tool to find previously unknown patterns and relationships in huge data sets. These tools can incorporate statistical models, mathematical algorithms, and machine learning techniques. These techniques are able to find the information within the data that requires the report can't effectively reveal. Like approaches of data mining in education data. Data mining is the branch of computer science that targets to discover different factors and patterns to help decision making. The model in the given figure aims to design educational data mining. Data mining can encourage institutional memory. Data mining, also known as KDD, knowledge discovery in databases, refers to mining or extracting knowledgeable data from huge data sets. An educational system typically has a huge educational databases. These data may include teachers' data, accounts data, students' data, alumni data, etc. There can be a various type of data like the organization can store. The educational data mining focuses on the development of techniques for exploring the special types of data that originate from educational contexts. The data originate from various sources, including data from the traditional face-to-face classroom environment, online courseware, educational software, etc. This is the chart, like the explanation about the educational data mining. This is the brief introduction. There are three types of mining, like ways. Professor database, like the professor can collect the students' marks, enrollment, or how many students can able to pass out with flying marks, or whatever the students are failing in that coursework. These can be professor database, like he can collect that, and student database also can be collected by the professor of that course, or maybe by the institution, whatever they have. And these are like data mining tasks. Like data mining tasks can be data analysis, descriptive modeling, productive modeling, patterns, and tasks. Like these are the tasks. And data mining methods: classification, clustering, association, temporal data, time series, web mining. Like these are the data mining methods. Data mining methods like predictive or descriptive, like we can predict the things like based off their previous mark. That student is getting 10 or 10 of out of like 100, then he is not doing well. And if the other student is also doing the same coursework and getting 90 out of 100, then he's doing good. And then we can predict that how good he is in studies, and where various kind of prediction you can make about the student, like what is he's gonna do in the next course or related to that course. And data processing, educational information system, like can be records, events, transaction, and messages. Implement analysis, model analysis. This is the brief introduction about educational data mining. data mining methods are used to operate on huge data sets to find hidden patterns and relationships, which is helpful for many organizations to make data-driven decisions. Various techniques and algorithms such as clustering, classification, regression, neural networks, artificial intelligence, association rules, genetic algorithm, decision tree, etc. are used to knowledge discovery from databases (KDD). These methods fall into following general category: prediction, clustering, relation, mining, discovery, and models, and distillation of data for human judgment. Okay, this is the paper. This author was also there, like Ren Baker. He was one of the eminent person there. I don't know, like I didn't have a talk with him, but he seemed to be very knowledgeable in this area. Tables like methods, category of methods, prediction. We can predict, like this is the table. Category of the method, goal of method, key applications, prediction. Develop a model which can infer a single aspect of data, predicted variable from some combination of other aspect of data, predictor variables. A key application will be detecting students' behavior, gaming the system of task behavior, sleeping, developing domain models, predicting and understanding students' educational outcome, clustering. The next type will be clustering. Find data points that naturally group together, discovery of splitting full data set into set of category, discovery of new student behavior patterns, investigating similarities and differences between schools, like collecting the data from all regional schools and then understanding the behavior of the students. Relationship mining, discover relationship between variables, discovery of curricular association in course sequence, discovering which pedagogical strategies lead to more effective, robust learning. Discovery with models, like a model of phenomena developed with prediction, clustering, or knowledge engineering is used in component and further prediction or relationship mining. Discovery of relationship between students' behavior and students' characteristic or contextual variables, analysis of research questions across wide variety of contexts, distillation of data for human judgment. Data is distilled to enable a human to quickly identify or classify features of the data. Human identification of patterns in student learning, behavior, or collaboration, labeling data for use in later development of prediction models. This is the chart. These are the techniques the professor who presented their paper there just explain. So I'm giving a brief introduction. I don't know what's that mean in like a detail because I'm not that well informed. So let's proceed further for next. What is the meaning of MOOC? Massive Open Learning Course. A massive open online course is a web-based distance learning platform that is designed for large numbers of geographical dispersed students. A MOOC may be patterned on a college or university course or be less structured. I read one article about this, and this explains everything very detailed. Yeah, a massive open online course is aimed to unlimited participation and open access via the web. In addition to traditional course materials such as film lecture readings, and problem sets. Many MOOC provide interactive courses with user forums or social media discussion to support community interaction among students, professors, and teaching assistants, as well as in immediate feedback to quick quizzes and assignments. MOOC are widely research development in distance education, first introduced in 2008, that emerged as popular mode of learning in 2012, a year called Year of MOOC. Okay. History, I'm not gonna say emergence of. Yeah, students served by. This is the data actually. So I'm not thinking about doing this deep. Let's skip this thing. Sorry. The next thing is the open framework. The open science framework is the tool that promote open centralized workflows by enabling capture of different aspects and products of the research life cycles, including developing a research idea, designing a study, storing and analyzing data, collected data, and writing and publishing reports and papers. Association data mining. This thing. This is actually a website, or you can say organization. It is open source. Open source. Actually, it is free, and it like we can publish our reports data, and any GitHub repo also can be linked with that. This thing I actually made account today only, so I have like this, like they provide these things. Thank you for free open source service maintained by the Center for Open Science. Here are a few things you can do with OSF. Select your storage location, like we can store like unlimited of data here. Store your files, share your work, like you can share with anybody, like it's gonna be openly available, so anybody can use. Like open source thing we have, register your research, and it will be like you can register your research also, make your work citable, measure your impact, and connect services that you use, collaborate. Like we can use GitHub, Dropbox, Google Drive. Like these have also integration there, so that's a good thing. One professor have detailed tutorial about how to use this for research purposes. He explained it very detailedly, so I'm also thinking about incorporating this OSF in our project. So whatever documentation I will write in future, so I will upload here with the GitHub link, so both the things will work together. So this is the good thing I actually learned there. This is the only thing I understand, rest I don't. And there is also LLM. The large language model is a typical artificial intelligence algorithm that use deep learning techniques and massively large data sets to understand, summarize, generate, and predict new content. The term generative AI also is closely connected with LLMs, which are in fact a type of generative AI that is also been specifically architected to help generative text-based content. Like these are the it's taking time. I think yeah, these were the papers discussed in the conference. Actually, I was talking about Aaron Hem. He explained about how to open science debugging reproducibility within the educational data mining conference. He actually introduced the OSF concept in the conference, and rest I don't remember that much. Yeah, I don't remember. Sorry. These were the short papers, and actually they have not uploaded it fully. Just these are the titles. They will be uploading within a week. So after looking back at the papers and reading it, then I will get to know like what it is. They just presented it there, so I don't recall it actually that nicely. And these were the poster. This was also I posted, like uploaded on our Slack channel. I really got excited about this poster only because rest I couldn't understand or figure out like what will be use case of in my thing. But yeah, exploring students' learning process by logging and analyzing their interaction behavior in a virtual reality learning environment. And this is by Antony Prakash, IIT Bombay. He made a software where we can track the movement of the person who is in the VR, like controllers, what he's pressing the buttons, where he's going, like moving forward, moving backward, like all data can be collected by this. He implemented this thing, and like at the end, my experience, I am excited to share that I attended the 16th conference, International Conference on Educational Data Mining. I talked about ISC Bangalore. Got opportunity to meet and interact with N.R. Narayan Murthy, sir, founder of Infosys, IT company in the India, like huge IT company. And Anand Deshpande, founder of Persistent System, eminent professor Jeffrey Ullman, Stanford University, and many more professors from IIT, ISC, and around the world. Jeffrey Ullman talked about one thing like AI can replace us if we can't use AI for like knowledging us. Like they are like one professor like describes his study like who used ChatGPT. Only in USA, only just 40% to 30% use ChatGPT. Like the average age for using ChatGPT is around 15 to 35. Like rest don't know about ChatGPT, or else they don't find it useful to use. Like these are the people who don't use ChatGPT. So there are study like only those people who incorporate with AI, like learnings, like what is the advancement in AI, because AI is moving so fast. So those people will be only sustained in future. Like this is about technological aspect, or else they like only these people will have a impact in their lives if ChatGPT will or any generative AI based model will be more intelligent than human. There were also one study where a professor designed the question where ChatGPT cannot give answers. Like they framed the question in that way, like keeping the thing in mind that this algorithm will be used by the ChatGPT, and we should frame the question in such a way like ChatGPT cannot answer it. So human brain has to develop its capabilities to answer the questions. These studies were like published by the ISC computation department professor. So he knows like how ChatGPT or other generative AIs work, and how we can, like the teachers or other people can use or like track down the algorithm and frame the question in such a manner that children's or whatever students cannot answer the questions with the help of ChatGPT. And Professor Jeffrey Ullman also said that like there should be a limit in using the GPT. Like we can use GPT, it's free. Like LLM model, it is free, but the extent we use, that has to be matter. Like if we are using it for fully answering the question for students, then it's not gonna help them like gaining the knowledge. But if he's using and then doing some work by himself and understanding the things by his own, then it's gonna help him in a long run, like he said. That's first, like let's go back to the track. First day started with tutorials on core methods in educational data mining and introduction in neural networks and uses in EDM, an inaugural address by Narayan Murthy sir, followed by a great keynote by Jeffrey Ullman. Like I will post it later. During the conference, various key talk, panel sessions, and great paper presentation took place. Keynote talk on leaf learning and evidence analytics framework in Japan by Professor Hiroaki Ogata, Kyoto University, Japan, discussed the leaf words, that are the different components and how it is implemented. Keynote talk on towards AI powered data informed education, a great session by Anand Deshpande sir on amplifying human potential and how to use the ASRA and the second orbit are helping small companies and future entrepreneurs. The key part of the session, which I like the most, is about the 4 stages of planning the career. A very useful session, the excellent panel session where they are on various topics like mock, which member of Berlin, IIT, Triple IT, Bangalore, Israel University, and IIT Madras showcase various initiatives taken by them. Professor Andrew from IIT Madras present about details about NPTEL. NPTEL is kind of Coursera in India, where this is government approved and only you have to pay for the exam fees, like 1,000K, which might be around 11 to 12 USD. So that's only, you don't have to pay for any tuition fees, whatever. It is kind of the mock massive open online courses available in India. You can also use it. There are various courses on various topics. I actually enrolled in computational neuroscience and data science courses there. These are like very well informed. Panel session on education in the age of generative AI discussed cheating using AI, the role of ChatGPT, how to frame the questions, and a lot more. The important panel session which I was very much interested was the very informative, is on national education policy in the India. Various panel member, including the consultant of NEP, presented important points. What are different opportunity? What are the different challenges, and a lot more. The conference was a great opportunity for me to learn about the latest advancement in educational data mining and to interact with various professors, researchers, and academics around the globe. The networking opportunity I got is really unbelievable, and also helped me to gain exposure to the field of educational data mining, and looking forward to implement the things that I learned in the experience during the conference. That's it. Thank you. Thank you for listening. This was a huge thing.
That's great. Yeah, thank you. That's wonderful. Very good. Yeah, there are a lot of things to follow up on. We can do that in the Slack, or other. We can do it in the open source meetings, even if you would like to follow up on some of these points. So yeah, there's a lot of interesting trends in education with like ChatGPT and with VR and with MOOCs. We haven't talked about MOOCs that much, but yeah. So Jesse wanted to know if you could share a link to the conference website.
Yes.
Yeah, that was good. Excuse me.
So yeah, thank you again. That's great. Ankit, hello.
Hello.
How are you?
Yeah, so yesterday I think I was talking that I wanted to share something. Am I right?
Yeah.
So right now I don't have access to my computer, but I think I can share the screenshot or like the link, and maybe like Jesse, you can show that. Are
Okay.
you fine with that?
Yeah.
Okay.
Yeah, cool. Give me a second.
All right.
But yeah, that was really good, Vrushali. I may ask a few more questions about it later, but it's very good to go through that, and it's always good. It's really good to share experiences
Yeah,
and learn how to write
actually, it
about
was
them.
so overwhelming for me. Like, I'm only undergrad student, and they were all were PhD and professor out there, and I don't know what to do.
Right.
That was nice. First
Yeah,
conference I attended, and yeah, that was cool experience.
absolutely. And you should be very,
First year, actually, I'm a first year student. Like, completed my first year, and my vacation is going on. And this upcoming semester, I will be in second year.
yeah, it's really good to do that and get experience. Even just like the process of getting used to it looks like it was in person that you were at because you saw the were you with the poster like was it in person the whole time? Okay, yeah, like it's really good to do that and like learn how to just be around the people and the environment and look at posters and talk and realize like oh yeah you can do that and things the more you do it the more familiar it gets and the more things kind of slow down like the less uncertainty there is. So it's really good to do this and start uh, getting used to all that. I'm sure we'll have many more things in the future, and it's really cool to hear like things like open science framework. We talked about that a lot in the lab. We use that for some of our projects. So maybe that's something we can follow up on later too, specifically because there's a really nice tie into efforts here in the United States and elsewhere for like data management, open data, and how they're affecting grants and funding in grad school and research down the road. So it's interesting to see it from the education specific perspective here, and then to see where things are going with that too. But yeah, thank you for that, Vrushali, and writing the report up. That report could pretty easily become like a blog post on our Medium if you want to submit it there too. Like the cool thing about doing stuff like that is once you put it out, even if it's kind of just putting it all out in one space, then you can easily repurpose it. You can make that a blog, you can make that an article, you can put it into a different kind of presentation. So it's good to do all that work.
Yeah, I would encourage you to do that. Like, we can edit it with images and things, or I mean, because the different medium or different media have different sort of ways that you have to present it. But I think blog post we could easily adapt that. I don't think it's too hard. But
Yeah, I think there's a really nice way to put all that into like a Medium, like put it on our Medium. And we can edit it. Bradley edits. It helps a lot. I'm happy to help.
Yeah.
Editing as need be, but like it's pretty easy to put that in just it's quite similar to what I just did with my own like the We Robot stuff. Just like read. It's always I think it's one of the better things we can do on the post as sort of like doing work stuff. Like I really like the idea of commenting on events because events are things people have access to otherwise, and it's a little easier. It's kind of like Amanda and I have talked a bit about it's easier to make public facing content on things that are somewhat already public, just because it's a reference point other people can deal with. And so these are really great things to just talk about. And get experience writing about having people come to you and say, "Hey, oh, I saw this," and you talk about it. That's good.
Okay. Yeah, I think Ankit is
Yeah,
sent the link.
so I've shared like 2 links on like admin lab. If you want to like screen share, Jesse, like maybe let me know.
Okay, I see the links in the Oh, okay. I see they're like covers. Let me put this here. Yeah.
Oh, wow.
This.
Yeah, so basically, like you were writing about a media review, right? So I thought, like, how about like we make it a little bit more formal? Oops, 1 second. Yeah, sorry. So how about we make it like a little bit more formal and like make a write up so that it's like a lot more easily like shareable for like social media platform. So I thought like if we could like write in a good document, then it would be great when we share it on like all these platforms, such as like we could put it up on LinkedIn. Maybe you could put like some snapshots of it on like Twitter and stuff. So yeah, so these are like the 2 current like versions I've like made. I have few other ideas as well, but I wanted to like first get some feedback on like what do you think about it, improvements, so that if there's other versions, then definitely I could like iterate. Yeah, and I was thinking like it's like I think we always like have like a annual recap as well. So like I've seen like I've always found that like like recently I think I remember I shared this white paper by Coursera like about like how people are learning, etc. The thought like how about like our lab could have like something that resembled a white paper but like was a little bit more like a looked a little bit better and lot more formal. So I just one day I was like, okay, let me just design something. So this is what I've like came up with at the moment. Yeah.
Oh, this is great.
No, that's nice.
Yeah,
like
this looks great.
even just getting the even like this is really helpful because it's just even I know a lot of this like generic content here, but like we could easily fill this in with our stuff, you know. And like this, the way it's framed and the way it looks, I think that's a nice thing to do. What do you think?
Yeah, that's great. It looks great. What did you make it in? Like PageMaker or some other, or just like what program? In Canva. Okay. Yeah, that looks great. And you know, um, yeah. So we've talked. Actually, we were also doing some things with slide templates too, and that's where you had added some slide templates. So I have those, and I put them in the main template. So we have a templates file where if people are interested, if they want to design a presentation for a conference, we can do like an intro slide with some of the logo and affiliation stuff, and then have like a template where we have some sort of design like this, where you put in graphics and organize it. So yeah, we have that, and then this is nice. This is a nice, I think, template for doing some reports. I know Jesse probably could adapt this pretty easily. Is Canva something that's open source? I'm not familiar with it actually.
It can be. Like I've used it before. I'm familiar with it.
Okay.
I forget how you.
It has like free and paid tiers.
Okay. Yeah.
But you can use it free. You can use a lot of stuff free as well. Yeah.
Yeah. I mean that's good. And so yeah, let's do something with that. Yeah, thank you, Ankit, for showing that. It looked great. I think.
Yeah, it's because I don't think we've really done anything. We've done these sort of like different reports or like blog posts or things like that, and I think right now is a really nice time to do it. I don't something this nice maybe like once a year, but like still like I think we should do it. I think I think it's a good upgrade, and like it could be formal, it could be like those online publications or something like that.
Right.
Not like magazine. It
Right.
looks like that. Like you
Yeah.
go there and it's like a more formal document that you can.
Yeah, a little bit like the magazine. Yeah, actually, like I remember, like last year as well. Like I don't remember which conference it was, but I saw like I've always noticed like these which CMU guys, they always have some really like good designs. So I was like, we should also do something similar to that. So that was definitely like the magazine style was definitely sort of like an inspiration from my end.
I think we have enough like the thing too, which is good. I'll share for those who haven't seen this. This is what it's called here. Like this, I'm going to share the source file. So I along with some other folks have been working on this. But like we have a lot of content here, even if it's just the events are fun because there's a lot of images to throw at that. But also like the banner updates are really nice things. I may reorganize it differently for that kind of a layout. But like the content here is really good. And then I know Bradley, we kind of have fleshed out this space a little bit more. And the deep dives, like, etc. Even it would be really easy to kind of just put this into this format and lay it out here, and it'd be really great. I don't know, something nicely tailored to external focus, and we haven't done a whole lot of like for people totally external to the lab with no context. Because we could easily do like this stuff and then even a little bit of like at the end, which is kind of, I think I removed this part, but like these sort of like back burner topics, just things that are actually going on in the lab that aren't here, but having that all be like here would be pretty cool. So yeah, this is good stuff.
Yeah, we could profile things that we usually don't talk about, like, and it's just like, things that we don't talk about so much. Let's talk about them here and showcase them.
Yeah, and the thing is, like, one of the things I take away from writing this is that even if it's literally 2 to 3 sentences, if they're like good quality sentences that can capture the space of our discussions and ideas very well. And I think that's really appealing for externally facing stuff.
Yeah, doesn't have to be verbose. Yeah, but the quality of the sentences is always the problem, isn't it?
That's
Yeah.
Quality of the sentences is why number one, like ChatGPT may not be replacing the effort to do that one yet, and then also it's hard for me.
Yeah.
It's hard to write. It's in the mind it's easy, like, oh yeah, it's just a couple sentences, but in reality it's like, well, if I say it this way, then everybody's gonna think that, and I don't really want to say that. I want to say this, and I really want to talk about this in the context of where I'm going over here. But if I say it that way, we're going to go in the wrong direction.
Yeah,
and that's like 3 hours for 1 hour per sentence of that break into this stuff. So that's why what I'm trying to do so much is like, if I'm in the writing flow state, I gotta capture that zone of writing, because then it's a lot easier.
Yeah.
Anyway,
All
this
right.
is great, Ankit. Thank you so much for this. And definitely let's we gotta finish a little bit of content. The design work is there, it's great.
Yeah, sure. So, as of now, what I had thought about in mind is that, like obviously, I think doing this would be sufficient for like, I think like twice a year, maybe like a mid-year review and then like a closing, like end of year recap. That I think should be like sufficient in my like personal like opinion. Other than that, if anyone wants to like adapt it like for their own thing, then school. But other than that, like if like from the lab perspective, I think only like the end year recap and the middle year review, that I think makes sense. For the content, I think as what you said, like yeah, I think first obviously I think we write it in the Google Doc because it will like make sure that you'll have flow, and then maybe you can adapt it to this particular document. So I'll share the edit links to the document to you at the moment, so that you can make sure like what particular content you want, because I looked at the document and it's a little bit over the place at the moment, but I had put in the important like the headings that I thought that would be uh, uh, like valuable with respect to this particular context. But other than that, if there's like any other like changes to like the main content, then I think that would be like more of like an editing focus that I think Jesse and Bradley, like if you want to make changes, that you should do. Finally, I think I was just thinking that like a good way to like showcase this like on Twitter would be that we could probably like take the screenshot of the first page, the screenshot of like the contents, followed by some one or two pages, and make it in the form of like a thread. So that is something that like I can envision at the moment, like in terms of like sharing. Other than that, I think I've covered everything. Like if you want like any other like iteration of like the cover, then definitely I would be interested. Like you can maybe message personally, like if you want like a different kind of design, because I'm a little bit need of ideas as well. Yeah, that's it at the moment. So yeah, I'll give the link to Jesse so that you can like edit it. Yeah.
Yeah, it's great. Thank you. Yeah, I look forward to working with it. It looks great. And again, with the report, we can do this in multiple media. So we can do this in the template, style where we have graphic design elements, and then we can have some of it, not all of it, on or as a series of Medium posts. So we could have like if we wanted to talk about the different parts, it might be good to have just like one section on per Medium post. So we'd have a series on like what have we been doing this past year or past half year, and just it's just easier for people to fixate on. So I mean, really, when you work on these documents, the thing you have to remember is like there's a certain amount of information that people want to read in a certain setting. So like the Medium posts often have like a number of minutes that it takes to read the article, sort of in the tagline. So it's like this post 4-minute read or 5-minute read. I don't know how they estimate it, just kind of like an average number of words per minute, but it's like people are going to say, okay, I can read this in like 4 minutes. So that's
I really, and to kind of follow up on all this is I think this is kind of implicitly stated and somewhat explicitly too. What's really nice about the report idea, and kind of why one of the things I've been trying to sort out with the Word document that we've seen, where it's just a Google Doc of all the stuff, is that I think the true form of it, yes, exactly. I'm trying to bridge those two comments. The true form of what I was the document is a full report, and it's nice to do right now because there's a lot of fun stuff to talk about that's easily accessible. Like we've been through a lot of things this year that are really that really kind of represent not 100%, but really cover a pretty strong depth of things, from NICWIC to embodied intelligence to Neuromatch to stuff with DevoWorm and Google Summer of Code. Like there's a lot of different things going on there. And I think that's, including DevoWorm related stuff, that I think even a full report, I'm thinking like the full, like if this is a true report, it would even say a little bit more about some of that inner work, just because people don't know what is that, you know. So and then I think breaking it down into, okay, here's, you know, and what people do, like in whether it's like Stanford HAI, you know, they have a lot of, they do this stuff all the time. I make a report and it's like, okay,
Oh,
here's
yes,
specialty
yes.
content, you know.
Stanford, yeah. I've been reading their reports. They are quite well made. Yes, yeah, that
Right.
was the, yeah.
And then it's like they'll take different content, so I have an interview, and I was thinking like, oh, we can have an interview where I sit down with Bradley, I sit down with Ankit, we talk about their experience of this thing, or oh, you wrote this part, or you were at this event, how did that relate to what we said in the report, and like all the, and that's not saying we want to become a big, you know, media publishing company about our own stuff necessarily, but those are easy things that are like tenable and fun to do, and I think would. This fits a lot with my want for more of a discussion series about certain conversations to have, and it's a really nice fits with all of that well. So yeah, good stuff.
Yeah, thanks again, and good job. Okay, now I want to move on to some other things. Let me share my screen. So the first thing I wanted to feature here is that I've been making some videos inside of virtual and augmented reality, and I have some demos. Yeah. And so here, it's on our YouTube channel for the lab. So we have a channel, we have kind of a playlist. It's, I think it's, what is it called now? It's, what's the name of it? It's in here somewhere. Metaverse and Spatial Computing for Research. So it's this channel. If you view the full playlist, you'll get a sense of what that looks like. We have, you know, some things done in MetaQuest 2. We have some things done in Magic Leap, and we have some other things in here as well. So they're just demos of how to do like working in virtual reality and augmented reality. Some of the concepts that we talk about, because some of these concepts are pretty fuzzy, and you need to ground them in something. Like when I've given some of these talks, when we've kind of gone over these different topics and deep dives. You know, it's like I can't put an image to that thing, like a volumetric web browser. I really need to see the process of it being used to really understand it. So I've done a couple things with volumetric web browsers in here, and so I mean, you know, this is one of the problems that always come up with doing work on in like VR and AR is that you have to put sort of a, it's hard to describe what you're doing, you know, especially like, you know, in the past. I think people nowadays are a little bit more savvy about what those things are. If you mention something like you know, a web browser, you know, if you use the word web browser, people know what that is. But like maybe 15 years ago, if you were to describe one of these environments, it would be very hard for people to visualize it. So that's why I've done these videos, and they're just like, you know, short, from 3 minutes to 15 minutes. And, you know, check them out when you can. If you have comments, let me know. I'll be making more videos, and I just keep putting it in this playlist. Another thing I wanted to talk about was to go into Neuromatch week 2. So Neuromatch week 1, what I did was, you know, we've done this in years past where we've looked at the curriculum and everything. But last week I went to Conrad Cording does kind of like an open question and answer session for each week. So last week I kind of picked some things out of that discussion, and I pulled up some papers, and I did the same thing for this week. So I think, you know, these question and answer sessions are nice because it's people asking different questions about the field, about interdisciplinary research, about, you know, different things that they're learning in the course. So I think it's really kind of informative. It goes in a lot of directions. So the first problem, you know, they had some questions on choosing a good scientific problem. So they had some questions about how to do interdisciplinary research, how to choose a good scientific problem, which is one of the things that kind of came up in this discussion. So this is actually a paper on how to choose a good scientific problem. This is Yuri Alan, who's a systems biologist. And so this is a nice little reference paper if you're interested in kind of thinking about how to find a problem to work on. And sometimes it's good if you're even in a disciplinary field or even in your own field, but you don't know exactly what problem to work on, where you have like a area you're interested, but you don't know exactly how to turn that into like a problem that you can tackle, in the short term to create a paper or something else. So choosing good problems is essential for being a good scientist. You can't just talk about a topic and then say, I'm going to do some experiments on some general thing. You have to pick kind of a problem that you're working on. And sometimes, it gets really in the weeds, which is, somewhat of an issue with relevance. And I guess we'll talk about this in this paper. But you really have to choose a good problem that's well defined to some extent. Sometimes there are problems that aren't very well defined. And this doesn't mean you shouldn't work on them. It just means that you have to sort of distill those into maybe more tractable problems that you can solve. Like you can't solve things that have no answer, or you can't solve things that have no way to, no mode of inquiry. So, if you can't design an experiment, well, you could ask a philosophical question, you could do a simulation. If you can't do those, then, it's kind of hard to do anything. You have to have a mode of inquiry. So choosing good problems is essential, but what is a good problem and how do you choose one? The subject is not usually discussed explicitly within our profession. Scientists are expected to be smart enough to figure it out on their own or through the observation of their teachers. So basically, you could be given a problem to work on, which isn't, it doesn't really teach the skill of finding a problem. You could talk to people and say, what is the problem that is most relevant to the field? And they'll tell you, oh yeah, we always had this problem with X, or we've never known anything about Y. that gives you some clue. This lack of explicit discussion leaves a vacuum that could lead to approaches such as choosing problems that can give results that merit publication in valued journals. So there's a lack of discussion about how to choose a problem, first of all, and then maybe what the current problems are. So occasionally people will publish papers that are like maybe like 10 open problems in field X. And we've gone through a couple of those in DevoWorm actually, where we'll, ask questions about, like, I think we recently talked about 101 problems in EvoDevo, or we've had some actually where we've discussed open problems that are posed by our community, and then we'll kind of enumerate them. And they're just problems that we're interested in as a group. Some are open problems in the field, some are just kind of curiosities. But those are things that you want to do, I think, on a regular basis, because it helps you think, and you pose and repose the problem. You say, I'm interested in, say, for example, learning. Okay, what about learning? Well, maybe like the predictive aspects of learning. Okay, what about the predictive aspects of learning? And you just move on from there. Or you might do some study and you might take that in context and say, okay, we learned this about, say, continual learning. What are the next steps? What are the next problems that we need to solve? So this is a way to decompose this seemingly difficult aspect of getting research done, started and done. So, when you start a research program, you have to kind of pick a set of problems to work on. Sometimes, people's goals seemingly are to publish the maximum number of papers of the highest quality, which isn't really a goal in and of itself. I guess it is, but it's it's maximization of a game, a number. You're gaming the system. So, but the question really is, what are you asking? What kinds of questions are you answering? And sometimes, that doesn't mean that you publish a lot of papers in the highest quality journals or whatever. Sometimes that means that you spend a lot of time kind of getting the problem right and then maybe putting out a paper once every 5 years. That's not necessarily a way to get ahead in the world, but in the world of high competitive, uh, that sort of environment, but it's. So, however, in this essay, we will frame the goal differently. A lab is a nurturing environment that aims to maximize the potential of students and scientists and as human beings. So, it kind of says there are two dimensions of the problem of choice of problem to work on. The first is feasibility, that is, whether a problem is hard or easy in units such as the expected time to completion or some other thing. We've talked about this in the open source meetings where your project is feasible if you can complete it in a certain time frame. If I want to investigate something that will take 10 years, I'm welcome to do that, but I have to understand that it's going to take 10 years at least to complete. So you might want to break that down into smaller units. You don't want to spend 10 years on a huge manuscript and then dump it on the world and no one has any context for it. If it's a hard problem, you want to break it down into parts that are easier, more tractable, and so forth. So there, some of this is about skills of researchers and the current technology. It's easy to say we're going to find the roots of behavior in the brain. That's a pretty broad question, but that's totally dependent on time of completion, skills of researchers, how they know how to use methods, and then the technologies that are available. So you couldn't ask certain questions 50 years ago that you can ask today, simply because we didn't have the technology at hand. The second axis is interest, or the increase in knowledge expected from the project. So how much knowledge do you get out of answering that or tackling that problem? Sometimes there's nothing new, so why do it? So this, then this paper goes through a range of problems in this space, and what kinds of problems are tractable, what kinds are efficient in the sense that I talked about, what kinds are informative. There are, of course, low-hanging fruit problems, like characterization or some other thing. Those are, good to have, but they're not necessarily the most challenging. So there are a lot of things to think about. In his lab, they have a rule for new students and postdocs: do not commit to a problem before 3 months have elapsed. So you wait 3 months and explore the field, and then you figure out what your problem is. In these 3 months, the new student or postdoc reads, discusses, and plans. The state of mind is focused on being rather than doing. So don't work on the problem immediately, just kind of absorb things and figure out where you're going. So this is an example here. There's a large gain in knowledge, a small gain in knowledge. The problem can either be hard or easy, and you want the easier problems with the largest gain in knowledge. That's the sort of sweet spot, and everything else is kind of has these trade-offs associated with them. The second thing is this is what they call a Pareto front, which is something they use in economics to characterize like a frontier of some phenomena, like it's an optimality frontier. So along that curve are the optimal solutions to problems. So this is the same sort of set of knowledge gain and tractability criterion, and they show a couple of examples. So the first problem for a beginning student would be a small gain in knowledge that's easy. That's kind of what we do here in the lab. We kind of, produces small artifacts. It gets someone in the mode of research. They don't necessarily gain a lot of knowledge, but they get, they get to put something out that's, just to give them some experience. And then for postdocs, you also want something maybe a little harder, but not too much harder, but have a large gain in knowledge. So you want to increase the amount of knowledge you're getting out of the problem, but not necessarily the hardness of the problem. And then the long-term problem for like a lab, which is going to be around for decades, hopefully, is that you have hard problems with a large gain in knowledge. And so this is a nice paper. People are interested. There's also, in this session, they talked a lot about hypothesis testing and machine learning, and they have this idea of a hypothesis space, or at least that's what Conrad called it. It's where you have the space of all possible hypotheses for a problem. So now you have your problem, you're looking for different hypotheses to test or to characterize your problem. And so this is a paper from Cognitive Science Journal. This is on learning problem-solving rules as searched through hypothesis space. So this is kind of something that we do in machine learning. We do, of course, a lot of exploratory research, but we also do sort of addressing things in a hypothesis space. We're testing a lot of hypotheses simultaneously, and we're coming up with the best solutions to those. So I'm just going to go through the abstract of this. Learning to solve a class of problems can be characterized as a search through a space of hypotheses about the rules for solving these problems. A series of 4 experiments studied how different learning conditions affected the search among hypotheses. So this is where this isn't necessarily an automated system, this is just searching hypotheses. But we talk about the learning conditions. So if we're learning things about a problem or a field or a system, how are we searching that hypothesis space? So experiment 1 showed that a problem property, such as a computational difficulty or the level of, hardness of the problem, of the rules biased the search process and so affected learning. Experiment 2 examined the impact of examples as instructional tools and found that their effectiveness was determined by whether they uniquely pointed to the correct rule. So can you guide someone to the correct rule through some sort of instructional tool? So this would be like analogous to someone trying to sort of specify their problem through like large language model, just, trying to use that to guide them, or some sort of other guidance. And so this is kind of testing that. Experiment 3 compared verbal directions with examples and found that they could both guide search. The final experiment tried to improve learning by using more explicit verbal directions or by adding scaffolding to the example. So adding like prior knowledge to the example or verbal directions of someone like a lab head or something like that. While both manipulations improved learning still took the form of a search through a hypothesis space of possible rules. We describe a model that embodies 2 assumptions. One is that the instruction can bias the rules participants hypothesize, rather than being directly encoded into a rule. So this is where your hypotheses are biased by instruction. What you learn influences how you view the problem and how you ask the questions. This is, of course, shouldn't be surprising, but you think about this in a broader context. If you're not, if you're reading you're not really broadly reading the literature, or you're not immersed in the literature first, you can't really ask very good questions. And you can't really figure out what the problem space is or what the problem is. 2 is that participants do not have memory for past wrong hypotheses and are likely to retry them. So this is something where this happens in the scientific literature all the time. When you have a wrong hypothesis, and especially if we don't publish our negative results, which happens, it's an issue with it's an issue in science, let's just say. But if you don't let people know that those are wrong, and people know that they're wrong or know that they've been tried, then people will try them and fail again because they didn't know. So this is an interesting point from the perspective of how science is practiced and how we might fix some of these problems. So having a good characterization of the hypothesis space is important. So they use a Markov model to model the data. And then, they kind of go through, they have some, they say these findings broaden our understanding of effective instruction and provide implications for instruction design. So that's like one thread that was happening. Ankit has a couple of points here. Would be nice to have a section or lab recap, so that was from the last discussion. Oh man, I should probably print this and the other paper by coordinating on how to write a research paper. Yeah, that was for the first paper. And then fun fact, also known as a Pareto front, optimal solutions and evolutionary optimization. Yeah, they use Pareto fronts in different optimization problems and things like that. So you'll run into that concept a lot. And so yeah, so those are that was the first thread. The second thread was about some of the stuff that sort of like on learning in the brain, and so the first thing was about this idea of making a connection between what's going on in the brain and behavior. And so in some of the projects that people are working on in Neuromatch, they have data sets that are trying to do that. They're trying to make like they might use a data set that has like measurements of behavior and some neuroimaging data, or some neural signals that map to behaviors, and then they're applying statistical models to try to analyze that and come up with hypotheses, come up with tests, statistical tests that show differences between conditions, and then that tells us something. So that's what people are doing in their projects. There's a more general question about what is the connection between behavior and what's going on in the brain. And so that's always, I think, a common thing that people ask when they're starting out in neuroscience or in computational neuroscience. So this paper, Natural Behavior is the Language of the Brain. This is kind of going over some of this. This is a review article. And so this is the summary. The breadth and complexity of natural behaviors inspires awe. It's a great sentence for a first sentence of an abstract. Understanding how our perceptions, actions, and internal thoughts arise from evolved circuits in the brain has motivated neuroscientists for generations. Researchers have traditionally approached this question by focusing on stereotyped behaviors. So stereotyped behaviors are kind of like if you know what a lordosis is in a rat. It's like when the rat is walking around, it bends its back, it arches its back. Sometimes it does that for reproduction. Sometimes it does it when it's pausing in space, or there are different things like that. The nematode C. elegans has a lot of stereotype behaviors, a lot of movement behaviors, like an omega turn, or like typical kind of forward and backward movement. Those are stereotype behaviors that you can easily characterize, and then also characterize the neural circuits that control them. So these stereotype behaviors can either be natural or trained in a limited number of model species. So they're not like a full range of behaviors, but they're the things that people have tended to study in neuroscience because they're easy to access and they're easy to understand. And so this is one problem in neuroscience, is that we focus on these problems that involve model systems. And this is true in biology as well as neuroscience. And the problem with that is that it doesn't represent the full range of things. So you can't really understand the brain if you're focused on these sort of model problems that are very easy to understand and solve, but very hard to generalize from. I mean, they're not hard to generalize from. We've had some success. It's just that that's a caveat, I think, that is really, I think for a beginner, is really important to understand. This approach has allowed for the isolation and systematic study of specific brain operations. This has allowed us to understand circuits in certain systems. You can't necessarily understand the circuit for, say, spontaneous behaviors, but that's the problem of observation. At the same time, the emphasis on experimental reductionism has left most aspects of natural behaviors that have shaped the evolution of the brain largely unexplored. So again, this is sort of a form of reductionism where we're just kind of focused on these subset of behaviors. They're easy, tractable problems, but they're not the full range of things we need to know to understand things. So this is where we need to really understand more about the brain. However, emerging technologies and analytical tools have made it possible to comprehensively link natural behaviors to neural activity across a broad range of ethological contexts and timescales. So, ethological context and timescales are where you're looking at animal behavior. Ethology is animal behavior, and you're looking at context. So, you're looking at if an animal is, say, a rat in a cage that's manipulating a maze, or being fed cheese in exchange for a button press, versus an animal that's out in the wild that's like foraging, and it's a different sort of context. And this is a thing that people have criticized a lot of lab experiments for, is that you put a rat in a lab and you basically take away its context. Sometimes you can enrich the cage with toys and things like that, and there's an effect of an environmental enrichment, but at the same time, the animal isn't doing the sort of the tasks that that animal is evolved to do in the environment that it's used to. So you're just kind of separating it from its context. You can get to these problems like these stereotype behaviors or these very isolated circuit inquiries, but you can't necessarily observe a lot of the natural behaviors that we're maybe curious about. Like, why do squirrels forage in the way they do? You can't understand that with a lab experiment in a model organism. And then the time scale is important because things happen in cognition at the very small scale, which we've really, I think, we understand it a lot better than, say, time scales of years to decades. So, like when you remember back several years ago or maybe several decades ago, that is, that's a memory that you build over that time. You do a lot of behavior in that time, and you consolidate things, and you do the behaviors over and over, and you encode some of those as memories, and memories get consolidated and modified, and so then you have an account of what you've done over the last several decades. So that's cognition, and that's a time scale we're not familiar with necessarily, and so that's different though from these isolated behaviors. So we will need to focus on natural behaviors instead of these lab-induced behaviors or lab-observed behaviors. So this paper, they describe a three-part roadmap that aims to leverage the wealth of behaviors and their naturally occurring distributions, meaning that you get this full range of observations, linking their variance with that of underlying neural processes to understand how the brain is able to successfully navigate the everyday challenges of animals' social and ecological landscapes. So this is just a wide review of this area. It just basically shows some of these behaviors. There's some conditioned behaviors, specialized behaviors, which are different things, but sometimes, we study behavior through conditioning. So we give, sort of almost like reinforcement learning, where we teach the organism how to do something, or, we study learning in the context of conditioning. If you give a rat cheese, they're motivated to do something, and you get the behavior that you desire. You observe that behavior, but there's specialized behaviors that occur in nature that don't actually work on that principle. Like a bird will sing. You don't need to. There isn't a direct reward for singing, but it nevertheless happens, and so you can observe that in a more naturalistic context and perhaps get a different answer than what you got with the conditioned behavior. They're different behavioral repertoires, only a fraction of which we can observe in the lab. So that's what they're getting at here. So I don't want to go through any more of this paper. I think that's kind of the point here. Conrad Cording and Friends, which is otherwise known as the Future Learning Collective. They put this preprint that has just that as the author. This is a paper they've done called Prospective Learning, which is principled extrapolation of the future. So what they're interested in this paper, as opposed to the last paper, is they're interested in how learning is a process that we can sort of understand as a link between the past, present, and future. So if we link all those together, that's learning. And so we usually think of learning as maybe like this tight feedback loop, maybe like updating priors and things like that. but it's, there's also especially like in machine learning and in reinforcement learning and computational models of it, you have these assumptions about learning. And so, sometimes these assumptions can be too optimistic or pessimistic for many problems in the real world. So in real world scenarios, learning evolves over multiple spatiotemporal scales. So, from like maybe several seconds to, several decades. Those are all different sort of processes. They're different things. They may be involving the same processes in different ways. So that's with partially predictable dynamics. So we can predict maybe how you might learn over like an hour or a day or a week or 10 years. It's only partially predictable though, and it depends on the time scale. So these are things we don't really know how to do in like machine learning and deep learning in those areas. Here we reformulate the learning problem to one that centers around this idea of dynamic futures that are partially learnable. So this is where you have this dynamic futures. We conjecture that certain sequences of tasks are not retrospectively learnable. So certain sequences of tasks, you can't learn them. So their data distribution is fixed. You can't learn them retrospectively, but are prospectively learnable, and which distributions may be dynamic. So the way they're approaching this is either have like things that have a fixed distribution versus things that have a dynamic distribution, where the distribution is changing. And so if you learn something, if the distribution is fixed, you learn something and you can just keep going back to that, and you can optimize your learning because you know kind of what's there. You know what the frequencies are. You can get a gist of what to expect. But in a lot of naturalistic contexts, things are prospectively learnable. In other words, the distributions are dynamic. If I see a set of faces, I can't I can memorize them, but you're constantly changing the stimulus. So this is something very different in the frequency of different types of faces. So this is very different from, like, say, a lab experiment where you would keep that variable controlled so that you don't have a lot of noise in your experimental sample. I mean, it's great for experimental observation and analysis. It's not great for actually understanding learning in the real world. So that's what they're getting at here. So these, having the difference between these two suggests that prospective learning is more difficult, of course, because you have to adapt to this changing distribution of things in the environment. So in other words, if a squirrel is out foraging for nuts and they bury them in caches and they keep going back to the same cache, they can learn that their caches are all over the place in space. They learn where those locations are, and they've mastered their environment with respect to where they've cached their resources. Now, if those caches changed position every once in a while or often, then the squirrel would be totally lost because they couldn't find their food, and so they'd have to learn a new strategy for doing that. But that's a different strategy than you would get if you kept those things fixed. And so that's the whole point, is that learning strategies are going to differ based on the underlying distribution of the things that are learned. So we argue that prospective learning more accurately characterizes many real-world problems that, one, currently stymie existing artificial intelligence research, or two, lack adequate explanations for how natural intelligences solve them. So we either don't know how to simulate it or don't really understand how they work properly. Thus, studying prospective learning will lead to deeper insights and solutions to currently vexing challenges in both natural and artificial intelligences. This brings me to this paper that I talked about yesterday's open source meeting. And I was talking about this in a very sort of general way. I'm interested in this area, what I call relativistic VR, relativity in VR, which is basically modeling different physical parameters in the environment in different speeds and things like that. It's really inspired by general and specific relativity in physics, and you have the tools, I think, to maybe start in that direction now. But this paper is actually more of a speculative piece on sort of merging the space-time of physics with sort of the past, present, and future experience of humans, or of animals, I guess. And so we experience time as this linear thing. There are physical reasons for that. Entropy unfolds in one direction, past, present, and future. And so our experience unfolds in past, present, and future. But we also live in these space-time which describe our spatial world and the interaction of time with space. And so this kind of goes through some of this. It talks about information gathering and utilizing systems, or IGUSs. And we are an IGUS. But in this paper, and I didn't talk about this in the meeting yesterday, it uses this robot, this model robot, to sort of understand information processing. And so this robot does, has this sort of these images, P0 to P3. You have this behavioral model here, which is where you have, let's see, the C schema and U. So I don't know if they mentioned what C and U are in here. Oh, conscious and unconscious. So this is a set of images. This is conscious processing, unconscious processing, and then a schema, which is usually like a mental model, and then that links to behavior. So this is the kind of the model he's using for this, where you have these different images. You're training the conscious state on one set of one image. The unconscious state is taking in a number of images simultaneously, feeding it through a schema, and then feeding it into the consciousness. This is kind of like, if you're taking in a lot of information versus what you're focusing on, and you're integrating that into like a mental model, you can change things in sort of the unconscious areas of that view, and you might not notice them. And so this is just kind of a play on that sort of model. But this is this robot that he's using, and he's kind of characterizing our perception through time of the environment. There's a model IGUS where they do these things in time. So there's this past, present, and future. So this fits right in with this idea of perspective learning, and then kind of goes through some of this, and then actually links this to theoretical space-time, and saying that the present is not a moment in time. Talks about a Minkowski space, which is sort of the embedding that you would use for relativity. And then this is an example of time flowing through sort of the past possibilities, the future possibilities, and the present. And the present is located in space-time, but the future expands outward in space-time. The past is funneling in from different possibilities in space-time. So you're constrained to some locations in the past. It brings you to the present, and then the future can be, sometimes there are constraints to what happens in the future, but it unfolds in space-time. So this is the idea here. And so it just kind of talks about this robot in the past, present, and future, and kind of gives some consideration. So it's a nice little theoretical frolic, but it kind of fits into this idea of learning. Finally, there was this discussion about things, how to find things from the brain, and talking about like causality and some of the things about associations and connections and networks. And so this led me to find this paper. Weak connections form an infinite number of patterns in the brain. So this paper is about we talk about brain networks as like voxels or neurons that are connected in a network. And the thing about networks is that they are these associations or these weak correlations that exist between two things. And so it's hard to really kind of gain an appreciation for causality from such a distributed network. It's just hard to make these statements. So the brain obviously isn't just a bunch of things all connected together. There's some selection, there's some sorting. And so, but nevertheless, because there are a lot of connections that are possible, you can have an infinite number of patterns in the brain. We actually talked about neural reuse during the Cognition Futures Group meeting on Wednesday. And this is an example kind of neural reuse where you have a behavior that's in a certain set of centers in the brain. And the way the individual neurons work is that they produce a number of different connectivity patterns as they as behavior emerges. So the abstract here is, recently much attention has been paid to interpreting the mechanisms for memory formation in terms of brain connectivity and dynamics. Within the plethora of collective states a complex network can exhibit, we show the phenomena of collective almost synchronization, just CAS, describes a state with an infinite number of patterns emerging in complex networks from recoupling strengths. So this is where you have this collective synchronization, but it's almost synchronization. And so why do they say almost? We show that a simulated neuron network with neurons of weakly connected connections. So they're not strongly connected. Sometimes they're associated with some neurons, sometimes they're associated with other neurons. The connection is weak on purpose. It does produce these CAS patterns, and additionally produces an output that optimally models experimental EEG signals. This work provides strong evidence that the brain operates locally in a CAS regime, allowing it to have unlimited number of dynamical patterns, a state that could explain the enormous memory capacity of the brain, and would give support to the idea that local clusters of neurons are sufficiently decorrelated to independently process information locally. So in other words, you have this network of neurons, it's a weak set of associations, so they can maybe be active at one time and inactive at another time. And that further leads to the ability to produce different types of patterns based on when they're needed, or sometimes a decorrelation process when local processing is preferred over global processing. So you can have this sort of moderation of those connections dynamically, and that's what they're getting at here. So this is this is a challenge for brain science, because we think in terms of effect sizes and correlations and causality. Sometimes maybe causality isn't really the question, or maybe the answer, but it's not an easy thing to wrap your head around if you're used to like standard experimental work. So let's see. Ox, I guess this is Jesse, asked, cognition and timescales. Are there anything, theories, papers, etc., about long timescales and impacts on cognition? There's some, but I mean, again, it's not a thing that's deeply studied. So there are a lot of papers on like historical memory, but they're not really neuroscience papers. It's more history or, things like that.
Yeah, I imagine it's really hard to study.
Yeah, it would be. Yeah.
It's to go back to the brain dance stuff from earlier today and the cyberpunk discussion. I in the back of my mind a lot is this, and even going into some of the relative VR stuff and everything else is like, in the one sense, the brain dance, as it's called in there, is it's extremely high, multi-dimensional, multimodal, multi-whatever, almost like multi-experiential, multi-perspective capturing, recording, which I don't, like, that really points out the interesting limitations of the tools we have and what they can record to get empirical stuff to prove or disprove the data. Like there's a I think I know this is like sci-fi stuff, but I think because we're talking about methodology so much, it's like, where is the methodological limits to getting data that is somewhat like data that we can analyze, and sometimes it's just hard. And so I wondered, you have the long-term stuff is juxtaposed to this immediate but totally immersive imaginary experience in the brain dance, where you have all the information and like bonus content. And it's like, I don't know, I think it's like a 20-foot sort of semi, I don't know, 10 foot radius, and then there's they're like limits, like, I don't know, 5 minutes of 10-foot radius of someone's total experience. Like, how much data would that be? How many like tera, etc. bytes of data would that be? Is the interesting about. And then like at the complete other end of the spectrum of what I'm thinking about with this is, what's like 10, 20, 30, 40 years of experience on a cognitive, like how do you even try to capture that kind of inertia or weight, and the meandering that would take place. Like it's not, the weight wouldn't be consistent across that time, you know. And then even going into like, oh, what about like multi-generational stuff? And there's stuff about memories across generations, like flies and other things, like implanting those things, like that kind of comes to my mind a little bit. But I feel like there's like these, I don't know if it's really the same spectrum or not, but two very different ends of totally immersive brain dance stuff, and then this almost like abstract but I don't know, permanent but long-standing, more abstract clouded presence that affects stuff too. And like those are just such, thinking about that and trying to, you know, understand like what would a cognitive science that actually can incorporate all of those things look like is like, you know, daunting, but something to think about. So,
Yeah.
I could say a lot about that, but and then I was curious if Conrad mentioned that paper specifically, or just it came up because you were talking about him.
Yeah, he did bring it up actually,
Oh,
and it was this group that they did. So this is I remember this paper from like a couple years ago, I think now, and so he did this under a pseudonym of this working group. But yeah, they're thinking about that. I think it's kind of like the maybe one side of the causality debate, like,
Yeah,
you know, you can generate these things that are sort of learned. They're very you know, obvious things, but you also have like, there are things in the world that I can learn the positions of things, and if things remain fixed in the world as they do in an experiment, it's fine. You can learn them and then you can measure the learning rate. But actually in the real world, things change all the time. So you learn new things, things change, you learn those things change, you learn those things. And so that's how learning actually proceeds. And it's like we're making this abstraction of learning for statistical and for experimental reasons so we can understand. And then, of course, in machine learning and deep learning and reinforcement learning, we're doing this so that it makes it easy, tractable to sort of build a system that's, you know, reactive at least, or can learn from the data. But of course, if you had a machine that was in the world, embedded in the world for years and years and years, they'd need to be able to handle these changing conditions. And people aren't ignorant of this. They've tried to study it in different ways out of distribution learning or maybe like perspective learning, but it's hard to do because you just simply just have to let the machine learn and, you know, and see what happens. And so but we don't really know how to characterize that actually, as far as I know. So it's a set of open problems, I guess. An open problem is this continual learning thing. We've talked about continual learning in the group before, but that it also relates to that. Okay, one last thing I'll mention before we go. This will be like a 10-minute thing, but I do have a couple follow-ups from. We've been talking about physical computation for a couple weeks. We did, I think, 3 features on it in the last 3 weeks, and then I actually have a few follow-up papers that I found in the literature. So just to stress sort of the nature of physical computation and what we're talking about. So let me share my screen again. So one thing that came up in our discussions of physical computation is that there's this aspect of universality. And so we talked about universality with respect to Stephen Wolfram's work on cellular automata, and some of those other, you know, there are other ways to look at universality, but it's basically the idea that, you know, there's this computational process that can be applied universally. It could be applied in a discrete dynamical computational system, and then those results should predict things in nature, physical systems, biological systems, behavioral systems, etc. At some level, they're basically equivalent. And so that's the idea. And so people have argued that Turing machines and something called spin models in physics, which is like a spin glass model of, you know, I'm not going to explain what that is here, but suffice it to say that those are also universal, or have this idea of universality. So this is a paper on where they're trying to sort of come up with a framework for universality, or a theoretical framework for universality. So this is not just in computer science, but in physics and then beyond, which means that these models are, give us an answer. Say if we simulate something in a cellular automata and we get some pattern formation, that it's roughly equivalent to some other pattern we find in another system. It's a controversial position, but it's basically what they're arguing. And so we set up a categorical framework for universality, which includes as instances universal Turing machines, universal spin models, NP completeness, which is a form of computational complexity, top of a preorder, denseness of a subset, and more. So these are just kind of like ways to sort information and look at sets and subsets. I mean, they're just looking at different properties of information to see, what is something that describes universality or characterizes it. By identifying necessary conditions for universality, so you want to have sort of the conditions, not everything is universal, but there have to be preconditions. We show that universal spin models cannot be finite. We also characterize when universality can be distinguished from a trivial one, I guess a trivial case where it's not universal, and use it to show that universal Turing machines are non-trivial in this sense. So you can have like a Turing machine or a spin model that's trivial, so it doesn't really predict anything else in the world. It's just the solution is unique to that thing in the computational world. Or you can have something that isn't trivial that actually describes things outside of that world. In a lot of ways, it's like a theory. Theories can be very relevant to a very specific area, but not necessarily predictive to other areas of, other areas of knowledge. So, you can think about like the brain. Do we have a theory of attention? Okay, a theory of attention might be involved with neurons and cognition, and that's very specific to attention, but not necessarily to learning and memory. By contrast, if we had a universal theory of the brain, which I think would be hard to do, we could actually have a theory that predicts attention and learning and memory equally as well. So that's the idea there. Our framework allows not only to compare universalities within each instance, but also instances themselves. We leveraged a fixed point theorem inspired a result by Lavier to establish that universality and negation give rise to unreachability. And this is something similar to what they call uncomputability, which means that you can't arrive at a solution for it. Uncomputability means you can't compute an answer. And so this is an interesting point that universality actually gives rise to this sort of unanswerability of a problem. As such, this work sets the basis for a unified approach to universality and invites a study of further examples within the framework. So that's universality, but also another theme that we had was that there were things like the collective behavior of granular matter and other types of systems that exhibit computation. And so there are two papers here. I won't talk about them too much, but just to point them out. This is, the title of this paper is Long Distance Electron Transport in Multicellular Freshwater Cable Bacteria. So this is basically computation in mud with the cable bacteria doing computation here where they're doing electron transport. And this is very similar to the stuff that we were talking about when we talked about Andy Adamatsky's work on slime molds and things like that. So, these are multicellular cable bacteria. They perform centimeter scale electron transport in a process that couples oxidation of an electron donor sulfide in deeper sediment to the reduction of an electron acceptor, oxygen or nitrate, near the surface. So they have these colonies that range from the surface to deeper in the sediment, and they transfer electrons across that gradient, and they're able to do this. They're doing electric metabolism, and this is something that they're doing. This is sort of this computational process that they're doing. 4 probe measurements of microelectrodes addressing intact cables demonstrate nanoampere currents up to 200 microns lengths, which is very small, 200 micron lengths at moderate driving voltages, allowing us to quantify the nanofiber conductivity at 0.1 s per centimeter. For freshwater cable bacteria filaments under our measurement conditions. Such a conductivity can support the remarkable sulfiide to oxygen electrical currents mediated by cable bacteria and sediments. So they're able to do these transfers of electrons through their colony. They go through this gradient from the surface to deeper into the sediment. They're able to make these chemical conversions and produce these currents that you can measure. And so that's one way of, the sort of computation in biological organisms interfacing with soil interface. The other paper I wanted to finish up with here is universal mechanism polycomputation in granular matter. And granular matter, of course, is like, mud or some sort of soil or, colloids, different particles that are sort of in contact. So there's this whole field of soft matter or soft active matter that is sort of, includes granular matter, includes other types of living systems like bacteria living in colonies, things like that. So this is relevant sort of to the biological aspect, but also relevant to sort of electronics and building microelectronics. Unconventional computing devices are increasingly of interest as they can operate in environments hostile to silicon-based electronics and can compute in ways traditional electronics cannot. So we want to build computers maybe in hostile environments that aren't amenable to traditional silicon-based electronics. So we want to be able to find things that compute. So information processing can be manifest on various physical substrates, one of which is granular matter. In a granular assembly, vibration can be treated as the information-bearing mode. So now we're using vibrations as the information-bearing mode. This can be exploited to realize polycomputing, something that's their term that they're introducing, or materials that can be evolved such that a single grain within them can report the result of multiple logical operations simultaneously at different frequencies without recourse to quantum effects. Basically, you can have a single grain can report the result of many logical operations simultaneously. So a single grain, which is here, it's getting this input, which is a vibration. It's getting, there are logic gates along this array, and it's reporting the results because the logic gates are summing different frequency modes together, or they're differentiating them, and then this is reported in these granular in these grains, and so you can measure the grains and their state, and so you can do this, and this is computation. This is what counts as physical computation, I guess. Here we demonstrate the evolution of a material in which one grain acts simultaneously as two different NAND gates at two different frequencies, and so NAND gates are sort of this universal gate. You can build a lot of different gates from NAND. Moreover, they are nonlinear, thus demonstrating a step towards general-purpose computationally dense mechanical computers. So this is, a nice sort of example of physical computation, but also of sort of digital computation being applied to different, non-silicon-based substrates. And so, that's all I have. Any comments or questions before we go?
Yeah, no questions, but those were really cool papers.
Yeah, I had to handle something else for the last few minutes, but as usual, I tried to take some notes in Notion, and looking forward to seeing all those other papers.
Yeah, so that's great. And so, I mean, I don't know where we go with this for the physical computation stuff. I know there's some interest in like moving forward on something with respect to that. I think it's a really interesting area, but I don't exactly know what that would be. So, I mean, that's something we can think about. I'm going to write up, I think, a thing on the different features and maybe a blog post where we can I can walk through a little bit. We have the video clips, we have the readings, and bring those together so we have a resource. But I think also we should try to do something more with it. And I don't know what we can do actually, but it'd be kind of interesting, whether it be a review paper or I don't know, something interesting and outside the box with respect to theory or whatever.
Well, I mean, there's some pretty interesting ties to some of the cognition features and method stuff, but I don't want to. I don't know if that's the best way to do it. Like, we could put it in the methods project theme.
Right.
I'm not trying to do that, but I feel like there's a lot of different angles for it. Like, there's an angle for this that's like history of science, kind of, like where are we with it now? There's an angle that's maybe cybernetic-ish related. There's an embodied intelligence angle. I don't know. I'm interested in doing something with it because I feel like it's getting at, like, for a question of interest is as it ties to even go back to the cyberpunk stuff. Like how can we do these things? So I don't know. I'm suddenly open a can of worms with that from my own sense of things. But we should talk about it more. Yeah.
Yeah, and then of course this coming week is the last week of Neuromatch. So next week's meeting, I'll talk about. So I'll come up with something for the last week of Neuromatch. But so we're finishing up that, and so I don't know. Maybe I'll give a retrospective of what maybe was learned from Neuromatch, and so that'll be good too. Okay, well, thank you for attending, and have a good vacation, Amanda, and have a good week.
Yeah, thank you.
Yeah.
All right. See you next time.
See you.
Bye-bye.
Bye.
See ya.
See ya.